Okay, so for these notes, we're going to talk about what an angle is, and we're going to kind of do this top section all together at once. So to start off with, we're going to talk about what actually the description of an angle is. So our description is that it's made from two rays. So we talked about what rays were in the last class, and we know that a ray has an endpoint, and then it goes on like this infinitely. It just keeps on going. So if it's made from two rays, we've got to add another ray over here. So an angle could look something like this. These are both rays. Then from there, we notice that they have this point that they have in common. So angles have a common, or the two rays have a common endpoint. And that endpoint is called a vertex. So this is our vertex, this point right here. All right, and then lastly, where the angle is. So an angle is in between the two rays. So it's actually measuring the amount of movement we're going from one to here as we kind of move like that. So this is our angle, is inside of the two. So we measure using degrees. So like 90 degrees or 45 degrees, we've kind of heard those terms in the past, and we use this little bubble or circle up there to signify the degrees. All right, so now let's talk about how we name these. So if we start from our rays, so let's say that we have a point here on our ray and a point here on our ray. So if this is point, we'll say point A, point B, and point C. So when we use these points, we want to use the point on the ray, then go to the vertex, then go to the point on the other ray. So when we name it, we're going to go, this is angle BAC. So this would be angle BAC. All right, the other way that you can name these angles, and this one, by the way, let me star this one. This is like the preferred way. As we go throughout the class this year, we're going to get more and more complicated in our figures, and so we're not just going to have one angle in the picture we're working with. We're going to have multiple angles, and it's just a lot easier and more precise if we use all three of these letters. However, right now, while we have some kind of basic picturing, we can use some other options as well. All right, so you can also use just the vertex. When we use just the vertex, you would just say that it's angle and then use whatever that vertex point is. So here it is A. And then the last one, sometimes inside of the angle here, you'll see a number. So let's say the number 1. So you can also use the numbered angle. So if you have a number in there, you can say that's angle 1. It's pretty easy. So let's do a couple of examples down here. So for this first example, we want to name write three names for this one angle. So we can start off by using just the vertex point, which would be angle Q. Then we can go with this 3-letter version, which is going to be the point on the ray, then to the vertex, and then the other point. So it would be P, Q, R. Always make sure that vertex point is in the middle. And then the other option we talked about is if it's numbered, but unfortunately this one's not numbered. So we can actually name it a third way, since the order of these points doesn't matter. We can, in the sense that it doesn't matter which point I start at, if I start at B and then go to A, or if I start at C and then go to A. So we went in this direction the first time, right here. We'll go in the opposite direction. So we'll call this angle RQP. All right. Next example, same thing. We can always start with our vertex, name it angle Y. That's easy. There's also a number inside of our angle, so we could call this angle 1. And then we could also always use the 3 letters, so we go from the point to the vertex to the point. So angle X, Y, and Z. And then example 3, same exact thing. We're going to start with our vertex. Sorry, there's something crawling on my leg. Okay. So we've got our vertex point here, so we can call this angle E. We can also call this angle 2. And then lastly, we're going to go from point to vertex to point. So we can go D. I said D and I wrote E. I'm sorry, guys. Angle D, E, F. I could have started with F and said FED. I just chose to start with D. All right, let's look at the next set, talking about angle addition postulate. So just like we did in the segment addition, where we had part of a segment plus part of a segment, if we added them together, it gave us the whole segment. So we can do the same thing with angles. So if we look here, this definition to me, I'll read it to you, but I think it just doesn't make a whole lot of sense. So we're going to try to make some sense out of it. So it says if K is in the interior of angle HIJ, so HIJ is this big angle out here, and K is in the interior. So like for example, you know what interior means. Your interior of your house versus the exterior of your house. So the inside versus the outside. So if K is on the inside of the angle, that makes sense. Then, and I'm going to color code these, then the measure of angle HIK, so HIK, so that's going to be this angle right here, plus the measure of angle KIJ, so KIJ, that's this angle here, that if I add them both together, it's going to give me the big angle, which is HIJ. So that's that big angle. So let's look at it if I was to put numbers with this. So say this angle here was, I don't know, like 60 degrees. And this angle here was 40 degrees. This is saying that if I added this angle plus this angle, it gives us the whole thing. So 60 plus 40 means that this whole big angle would be 100 degrees. Makes a little bit more sense when we put some numbers with it. All right, so going on to the example. So again, going to color code because I just think it helps. So it tells us that angle AOC is 70 degrees. So angle AOC is the bigger angle. That's this whole thing right here. It's 70 degrees. Then it tells us that the measure of angle AOB, oh, I wish that hadn't cut off. All right, so angle AOB is 1/2 2x plus 20. So AOB is going to be that angle. And then the lastly is angle BOC is angle X. So angle BOC is here. BOC. All right, so just like we did here, we're going to do 60 plus 40 to get to 100. We're going to do the same thing. We're going to do this angle here, AOB, plus this angle here, which is angle BOC, is going to equal the whole thing. And if you like to write out our equations using the angles like we did for segments when we wrote out the segment plus segment equals the whole line segment, that's fine. We can do that too. So if we have angle AOB plus angle BOC equals angle AOC. It's definitely not going to hurt you if you get familiar with writing these out. All right, so AOB, we're going to substitute in this 1/2 2x plus 20. So 1/2 plus 2x plus 20. Then angle BOC is just x. And then lastly, we have angle BOC or AOC, which is 70. All right, so we're going to start off by distributing 1/2 to both of these terms. So this becomes 1x and then plus 10. And then I'm not changing anything over here, so I'm just going to rewrite it. I have like terms on the same side of the equal sign, so this is going to be 2x plus 10 when I combine them. Subtract the 10 off both sides. I have more room now. I can show my work. This gives me 2x equals 60. Then I want to divide both sides by 2. So now x equals 30. So this is the first answer I'm looking for. So the next thing I can do is go down to measure BOC. So BOC was this pink angle. And we know that this was just x. So that means that this angle is just 30. So now I want to find angle AOB. So AOB was 1/2 times 2 times x, which is 30, plus 20. All right, so 1/2, and then 2 times 30 is going to give us 60. 60 plus 20 is 80, and then 1/2 times 80 is 40. So that angle is 40 degrees. We could have also just taken the 70 and subtracted this 30 to get that. That's also fine. You can do it that way. Just want to make sure I show you guys how to substitute. All right, next. Angle bisector. Just like we had the segment bisector, again, bisect means that we're cutting something, cuts into 2 equal parts. So this time, instead of cutting a segment into 2 equal parts, we're going to cut an angle into 2 equal parts. So let's see what that looks like. So it tells us if XZ, so that's this right here, is an angle bisector of angle WXY. So this whole angle was cut into 2 equal parts. So just like we put those little tick marks on the segments when we are marking them to be the same, we can do that on angles as well. So those little tick marks mean that those 2 angles equal each other. So we know that angle WXZ is equal to angle ZXY. All right, so let's look over here at what we've got. So it tells us that FG bisects, so that means FG is the thing that's bisecting. It's the one doing the cutting into 2 parts, and it's going to bisect angle EFH. So angle EFH is this whole big angle right here, and FG is cutting it in half. So that means this angle and this angle are equal to each other. So angle EFG is equal to angle GFH. So then let's look and see what other information they give us. So it says that the measure of angle GFH, so GFH, that's this one, is 1/2 10x minus 20. And that the measure of angle EFG is 3x plus 25. So EFG is 3x plus 25. That's this one. So I already know that these 2 angles are equal to each other. So that means I can set these 2 things equal to each other. So that's what I'm going to do. So EFG is the green one, so 3x plus 25. And then GFH is 1/2 10x minus 20. All right, so now I'm just going to solve these for x. I'm going to start off by distributing the 1/2 inside of the parentheses, not changing anything on the left-hand side of that equal sign. This becomes 5x minus 10. I'm going to subtract 3x from both sides, and I get 25 equals 2x minus 10. I'm going to add 10 to both sides, and I get 35 equals 2x. And then I divide both sides by 2. And yes, it's okay that we just got some funky, weird fraction. It's not a big deal. We can just leave it. Just like that. It's okay to leave it like that. I don't need you to convert it into a mixed number. Just leave it as an improper fraction. It's more common for you to use it like that this year as well as next year in Algebra 2. Okay, so moving on to finding the measurement of GFH. So GFH is this pink angle right here. So let's do the work down here. So the measure of angle GFH is 1/2 times 10 times, and this 35 times 2, or divided by 2, minus 20. Let's put that in parentheses. There we go. All right, so if you want, just trust me, if you want to do this by hand, go for it. It's 77.5. So that angle is going to be 77.5 degrees. The next, it wants us to find the measure of angle EFG. EFG is the green angle, and we know that this angle and this angle are the same. So we don't even have to do any math. We already know that this is also going to be 77.5 degrees. So in order to find angle EFH, which is EFH, we're going to add these two angles together, or you can do 77.5 times 2. So this is going to be 155. 155. All right, and then how many of you remember how many degrees it is if you have a straight line? So sometimes it helps if we draw it like this. If you go from here to here, how many degrees is that? Well, it's 180, right? Because it's half of a circle. So if this big angle is 180, that's that measure of angle IFE. So I'm going to do 180 minus the 155 that I used here to get this on this side. So if I do, oh, that's pink. Sorry, guys. Blue. All right, so the measure of angle IFE, we're going to do 180, because that's the total of this, all of this together, minus this part that we've already figured out that equals 155. So that means that that angle is 25 degrees. And this is really a perfect example on, that's this angle here, this year in this class, to make sure that you're actually calculating, checking your work, because these pictures aren't always drawn to scale. So this obviously doesn't look like a 25-degree angle. It looks more like it's closer to 90. So we want to just make sure that you know, you don't just assume things. You actually go through and solve these out so that you can make sure that you're right. All right.